I'm Hyun Nam from Naver Apps, and this is Joint Work with Jung Kim. In this talk, I'm going to present our dual attention networks for visual question answering. I apologize that some fonts will not be very look nice. This is the summary of our submissions. Our method won the second place in most of the real challenges, showing significant improvement over the recent VQA systems. The key component of our method is applying an attention mechanism on both question word and image regions. The motivations for our approach are as follows. First, we observe that the meaning of a question is usually delivered by a small number of keywords. For example, if you are given this image and the question with a single word weather, you might be able to guess the answer is sunny. Similarly, in this example, the single word question cooked might provide enough information to predict the answer yes. In addition, even if you are given the full sentence of the question, you might still focus on specific keywords that are highly relevant to the answer. In this sense, we argue that VQA systems also need to focus on the important words in the question as well as such regions in the image. The second motivation is that we often move our attention from words to words on the question for reasoning the answer. For instance, when the question is what color is the umbrella, you might first focus on the word umbrella and find the umbrella in the image. And then you move your attention to another word, color, so that you extract the color information from the umbrella. In this case, where the question is how many people are there, you first attend to the people, then you move your attention to how many, which indicates that you need to figure out the number of people. In this respect, we believe that a VQA system could be able to move attention through multiple steps using the memory of its previous attentions. Therefore, the goal of this work is twofold. The first goal is to build a dual attention mechanism to find the important words in the question as well as such regions in the image. The second one is multi-step attention and memory update to move attention dynamically on the question or the image. This is an overview of the proposed method, which is referred to as dual attention network. At the top and bottom, we have image and question input modules to extract feature vectors from the query, image, and question, respectively. At the center of the picture, there is the main block which performs visual and textual attentions and updates the memory the attention outputs. It is repeated for several steps, and finally the answer is predicted from the last memory. Now I'm going to explain each component in more detail. First, let me look over the image input module. We employ a pre-trained deep residual network with 152 layers, and we extract high-level feature vectors which correspond to 7x7 different image regions. The question input module consists of a single-layer bidirectional LSTM network, which is end-to-end trainable. The feature vector for each word is constructed by adding the hidden state from the forward and backward LSTMs. In this manner, each feature vector not only encodes the word itself, but also contains its context in the whole sentence. This property is essential to figure out which word represents the meaning of the whole sentence. Now I'm going to explain the dual attention mechanism, which is the crux of the method. It is divided into two alternating components, dual attention and memory update. First, it computes visual and textual context vectors by applying attention to the input feature vectors based on the previous memory. And then it updates the memory using the two context vectors. The visual and textual attention mechanisms are almost identical. We apply an element-wise multiplication to combine the separate hidden layers from an input feature vector and the memory vector. Then you compute the attention weight to obtain the context vector by weighted averaging. In case of the visual attention, we have an additional layer to match the dimension and scale. After we obtain the context vectors, we update the memory vector using the context vectors by simple element-wise multiplication and addition. In this way, the memory vector keeps track of all the visual and textual information that has been added to so far. This process is repeated for several steps to attend to different parts as well as enhance the attention quality. Finally, the answer is predicted by multiple classification to the most frequent answers. We employ a softmax linear classifier where the input is the final memory. The whole network is trained end-to-end except the CNN part. We use the standard mini-batch stochastic gradient descent with several generalization techniques. We also have an additional component which is applying multi-scale image features. In order to capture various scales of visual patterns, we train 3 models with different image scales and combine them by an ensemble technique. This approach improves the accuracy to some degree, which will be explained soon. Now let me show the experimental result and give an analysis of our method. These are the results on the VQA dataset. For the real open-ended task, our approach with a single scale model achieves 64.1% in the depth set, while the multi-scale model provides additional 0.8%. This is the comparison with previous VQA algorithms. I'm sorry about the font. For the question types, our method, either with or without ensemble, outperforms the other method with a significant margin. We also performed the evaluation study to verify the effectiveness of our dual attention approach. We compared 4 different models with different combinations of visual and textual attentions. And then we investigate how much effective each component is. This is the result from the experiment, which demonstrates that both visual and textual attentions are effective. Especially, the combination of visual and textual attentions improves the accuracy significantly. Finally, I'd like to show some qualitative results from our method. In this example of what color is the umbrella, the textual attention actually moves from umbrella to color while reasoning the answer. In addition, the visual attention becomes much precise with the help of textual attention. When we change the question with this one, it focuses on the keywords holding and hand and moves its visual attention to find something that he's holding with his hand. In this example, people, it sequentially attends to the word people and how many in figuring out the number of people in the image. when you give another question, is the water calm? It focuses on the keyword calm and the image area of water to infer the answer no. There are some more examples which show the benefit of our method. At the top, it initially just attends to the salient part in the image, but after it focuses on the keyword list, it moves the attention to the right place where it can find the answer. At the bottom, by focusing on the keyword spoon and made, it successfully figures out the spoon is made of wood. In these examples, our model discovers some indirect relations between word and image regions, such as the relation between country and national flags, and between wild and windows. To conclude, we proposed a dual attention network to apply attention on both question and images. It also contains multi-step memory update which enables moving attentions. This approach shows outstanding performance compared with previous method and second place in these real VQA challenges. Thank you for listening. Any question?